So let's review stacking faults, right? We passed these around the room, we talked about them, and we said that when you're thinking about stacking faults in crystals, many crystals have a stacking sequence to them. And two very good examples are the FCC and the HCP crystals. In the case of FCC, if you draw the 1, 1, 1 planes, for example, the red plane, you'll notice that, and I drew the red plane here in red, in this one atom, you'll notice that the red atoms stack together to make a hexagonal lattice. And I can expand on this a little bit. Like that. So we get this hexagonal set of triangles, because the plane extends out in all directions. Another way to draw the 1, 1, 1 is to draw this. And remember, I showed you in video that you can draw the same plane in different places in the crystal and still the same plane. So we can have the green and the red planes, and they don't. You notice here, looking in the 1, 1, 1 direction, they don't stack right on top of each other, but instead they sit in this tightly stacked placement. And in fact, you see here, I have these colored atoms that they sit in the holes. And they don't sit in all the holes, but they sit in half the holes. So for example, I have my red plane here, and the atoms that are on the red plane, see these edge ones, the corner ones, I drew those as red dots. And then I drew the green plane also on top of it, and you notice that where I've got the red plane, I have holes. Well, I only cover half of the holes in the hexagon, and I fill those with green atoms. And that's how this plane and this plane stack on top of each other. But if you notice, it only fills half the holes, so there's still holes that are going to still exist, and those holes will then be covered by the next set of atoms, the C atoms, and those C atoms are on either side. So you get the stacking sequence of A, B, C, A, B, C. And that was the stacking sequence in FCC. So you get A, B, C, A, B, C, dun, 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 dun. And we said that a stacking fault is a place in which we have, well, if it's an intrinsic stacking fault, it means that we're missing a plane of atoms. So for example, if I took this C out, I would have A, B, and then A, B, C, A, B, C, A, C, B, A. So right in here, I've created an intrinsic stacking fault by removing the C layer. And in doing that, I've created a sequence now that goes AB. And this AB stacking is what we find in the hexagonal closed pack structure. And the hexagonal closed pack structure, you have two hexagons on the top and the bottom, and then in the middle, you've got still hexagons, but if you look at the orange atoms aren't centered right on top or right between the atoms, but they're actually centered in the middle. So if I draw these triangles in a little bit more prevalent, you can see that goes down where the orange atom is, this where the orange atom is, and this is where the orange atom is. If I draw the blue planes and the orange planes on top of each other, again, you'll see that the orange atoms are sitting in the center of the triangles, and now we have these missing holes. And in the case of the HCP, those holes will always be missing because the next layer of B goes right on top, and we leave that open. Whereas in the FCC stacking, ABC, 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 we have those being filled every third plane. So the stacking sequence is A, B, A. Now, stacking faults are a form of defect. They're a two-dimensional form of defect. They can form in several different fashions. One is that if you're growing planes, so for example, you are doing some type of atomic deposition and you have a gaseous species coming down on the surface, and they stick, and that's how you're growing a material, you're growing a thin film. Well, you may just happen to start on the wrong position, and that happens sometimes, and you'll get grown in stacking faults. That can happen. Another place that stacking faults can come from is from dislocations. So when a dislocation passes, it can leave behind, still a perfect crystal, except that it has this stacking fault. And that is one class of dislocation which you'll see later in life in your material science background, talking about that type of dislocation that leaves stacking faults as it passes.